Thanks for taking the time to be here. So I guess to kick things off, when I talk to folks about ResearchHub and they hear that you're involved, they're kind of like, he's a cryptocurrency exchange owner. Like, why is he interested in science? So I wonder if you could just like speak for a moment about why you're excited about the problems in science and trying to fix it.
Yeah, for sure. Well, hope everyone's had a great day over there, and it's exciting to come in and chat a little bit about it. The goal of Research Hub here is really to accelerate the rate of progress in the world, accelerate science, and that's something I've always been passionate about. I mean, I feel like if you want a lever to improve the world, science and technology is the best way to do it, right? Even if you go back to the first person who discovered fire or stone tools or shoes or eyeglasses, like we don't think of those things as like the cutting edge of technology, but that's how you improve the human condition. And I had some friends who were scientists, and they would always tell me about these challenges that they had where like funding was scarce and peer review took too long. And, I was lucky enough to meet Joyce and some members of the team here. And at some point I was like, all right, I've been thinking about this for so long. We got to try to do something about it. And that was the birth of Research Hub.
Yeah, super cool. Very glad that you're going for it too. I think there's a lot of excitement here in this room. I'm wondering if you could give like a summary in your own words of like what you hope to accomplish with Research Hub's product.
Yeah. Well, there's so many challenges in science. I'm sure many of you in the room have experienced these firsthand or seen it as well, right? I mean, one thing is that there's just so many research papers that are published every year, and it's tough to kind of get signal out of it. Like, which of these are important? Most of them turn out to not have a huge impact. And so just getting signal on which are the most important ones is the first step. And then how do you actually get people to get better input and faster input on their work? Sometimes when peer reviews are happening, you can't tell like who the reviewer is. They're anonymous. Maybe they're in a competing lab. There's all these fees to get your paper submitted and have people review it. And sometimes it's not very helpful. Of course, there's like a whole replication crisis. Sometimes there's groupthink in science, just like in any field, where it's dangerous to come speak outside of the current orthodoxy. And then I think like if you zoom out, the biggest issue is that science is really great as a first step, but it doesn't really deliver value to the world unless it eventually gets commercialized and turned into products and services that people can really benefit from. And so that might sound like a massive set of problems, but I think Research Hub is just one small step in that direction, where we're getting started. But hopefully we can start to tackle some of these issues, like make the vast number of papers that are out there digestible, surface the ones that are most relevant to the top, allow people to get real-time feedback, whether that's peer reviews, like paid peer reviews, maybe even give them opportunities for additional alternative forms of funding. I think in the future, there's a lot more we can do about making it easier for people to license some of this technology to go commercialize it, or create prediction markets for how likely something is to replicate, make it okay for people to say things which are novel, contrarian ideas, and find, that other person somewhere on the other side of the world who has the other half of the puzzle that you've been thinking about, and somehow get you two linked up. And like, we see examples of that happening in open source software with this collaboration that happens. It'd be cool to bring some of that to science as well.
Yeah, super cool. And so I mentioned to everybody here, like the best part of this project is we've got like a community of scientists who like help us to build, which is I think a pretty unique thing. So we've got two questions from the community here. The first one is like, if Research Hub's mission is to accelerate science, how do you actually measure the impact? So like in 2035, what would you be looking towards to like actually see if we've accelerated science and made progress in the world?
And Joyce, you may have good thoughts on this too, so feel free to jump in. But I think there's a whole field of progress studies, right? And I think historically people looked at these measures that were kind of imperfect, right? Like they said, okay, how many patents were issued in these different areas, or how many papers got cited or published? And people sometimes say, oh, how many papers on AI or biotech got published out of China versus the US this year? And there's kind of these like very broad measures you could have, but they're not great. I think GDP is really downstream of science and technology, but it's influenced by so many other factors like the regulatory environment and rule of law, and are there peaceful transitions of power? Like it's a little bit of that would be almost like too broad of a measure. Like science and technology progress is just one input to that. So I think that some better ideas about measuring progress would be, I think you could look at some leading indicators and say, okay, what percentage of papers out of a certain field are replicating now? Are we seeing more replicatable papers? Maybe like time to publish, right? Like if you have a manuscript, you have it essentially done, and how long did it take you to get it all reviewed and edited and published, or did that take like 2 years, right? I think we should see the cost of these things, like the paywalls, go down to zero. Ideally, that would be like a leading indicator that it's just at least the barriers to going and consuming this or discovering what's out there are going down. And then I think longer term, so those would be kind of like the leading indicators, but the longer term indicator would have to be something like, what is the number of genuine breakthroughs that really happened in that given year, right, or decade, and come up with some definition of that. I think that for my own personal definition, I'd like, how would the general population start to feel like, science and technology are really benefiting my life? They need to see some of these breakthroughs deliver real world benefits to them, right? Like if you're the first time people use Starlink or something, they're like, wow, that's powerful. It's like amazing, right? Or this kind of baby KJ who got this first gene therapy, like people are like, wow, like this could cure genetic disease, right? Or if fusion energy manages to lower their electric bill. And so I know it's maybe a little bit contrarian in science, like because we like to think about these big open-ended explorations and basic research and like don't, touch the sanctity of that. But I don't think the general population will feel like we're really delivering acceleration in science until it affects their personal lives. And so I always try to think about, how do these discoveries get licensed, commercialized, and really benefit people? And there has to be some link to that eventually. Otherwise, why are we all working on this? But yeah, Joyce, I don't know if you have other thoughts you want to add.
No, I think that's a great answer. Sort of like what I was thinking about was an experience when I was in medical school. I was rotating through a psychiatry clinic, and like there were just a lot of people who came in who like we couldn't really help, and yeah, they just would try drug after drug after drug, and like it didn't really help. So I think like a lot of issues and kind of like public trust in science comes from this like lack of efficacy, So I think like if we could have drugs that could help to cure some of the biggest problems that exist, actually looking at like incidence rates of different diseases would make sense to me. But that's coming from a medical background. So yeah, the next question that I have here is another community question, kind of about the GitHub for science metaphor. So the question is, in software engineering, open source took decades to become an industry standard. What is the single biggest friction point preventing scientists from open sourcing their research? And how is ResearchHub going to build features to help remove it next year?
It's true. In science, I think there is a scarcity mindset around funding, right? And so people often will want to hide their work to make sure they're not tipping off somebody else. And then they'll only publish it when ready, as kind of to really get like a credibility signal that they're competing for, which could then get them whatever, the next grant or the promotion. So, it's okay I think if we're trying to build a new system here, it's okay if we don't attract maybe 100% of the people who've built, if they're getting consistently Nature papers funded Nature papers published and NIH funding, maybe they're not the early adopters of this, but it's a little bit like YouTube versus the traditional television networks, right? Like when YouTube first started off, there was some quirky content, is some of the early adopters, there was a younger generation. And now, you having like 1 million subscribers on YouTube is better than having a primetime TV show or something, right? It's more powerful, but that took a couple decades to do. So what can ResearchHub do in its own product? I mean, I think we have to create our own credibility indicators, right? Like help people advance their own goals and careers and funding. So just as an example, like on ResearchHub, we put together the ResearchHub journal. So if you have a sufficient number of peer reviews and it meets a sort of significance standard, you can get published in the ResearchHub journal, and that's the first step, right? Or just getting a certain number of upvotes or a certain number of followers. It's still early days, but I think that can grow over time as a credibility indicator that would cause people to post. Like on GitHub, if you're a software developer and you have an open source project on GitHub with 1,000 stars on it or something, that's a big deal. Like you can get multiple job offers for having that, and you're going to get invited to conferences, like all kinds of things. And so as we can build a community around open science, I think getting these number of upvotes, followers, et cetera, on ResearchHub will be powerful. And then I don't know, long term, maybe we need to do something like give out prizes, right? Like the Nobel Prize, right? But we should have the ResearchHub prize, and for truly breakthrough work that's not getting sufficient attention elsewhere, let's give these folks the attention and the credit and the really like funding and prize money that they deserve.
We just got a great question in the audience here after I gave my presentation, which to put, I think succinctly, like, hey, AIs are smarter than humans. Why are you wasting your time paying humans to do peer reviews? And so, I think that's a future thing, but probably will happen. So curious in general, kind of like what role you see for AI in scientific research, and like how can agents, artificial intelligence kind of be built into ResearchHub in a productive fashion?
I think there's going to be a huge impact from AI, obviously, just like in every other field. But I think AI agents are right on the cusp of starting to do novel science, most likely. I think there's some of these training sets people are doing where they'll cut off the training set, like let's say in the year 1900, and then see if this model or this agent can actually go discover the theory of relativity or something, right? It's sort of a test to see if it can do breakthrough research. And I think we're close to that. Maybe there's some examples people can point to where they've already seen some novel math proofs and things like that. Now, a lot of science, and if it's not already there today, it probably will be in a few years. I think that a lot of that kind of work can be done just purely in the cloud with like a math proof or something could probably be done just in the cloud and see what its output is from the model. But a lot of science requires moving atoms, right, in the real world. And I think the next big step is we're going to see these humanoid robots where they can, let's say you used an AI agent and you said, okay, I'm trying to discover this new material, with XYZ properties. And you could say to the agent, okay, help me put together a plan. Like, what kind of testing harness would I need to have? Like, what sort of different alloys would I put together? And it makes some suggestions based on, what are the existing attempts that have already been tried out there. It puts together a series of those, and it says, okay, you would want to put together this kind of testing harness in this sort of factory to run this throughput. And so if you had 10 or 100 of these humanoid robots, you could kind of go out there and say, okay, great, like, source the necessary parts, assemble it in the lab, like heat this alloy to, and it would almost go and implement the plan. And so I think that's probably still a little ways off, especially the humanoid robot part, but I could imagine a world in the future where people are doing that kind of science. Now on ResearchHub specifically, I think there's features that we can do a lot better with, like just if you want to get a question answered about a specific paper, like that should probably be very easy to do right on any paper page, or just providing a plain English summary of a paper for somebody who wants an easier time to digest it, like that would probably be good. Or if you're a scientist actually like drafting a paper or summarizing your results, like it should probably just give you the first draft of the paper with all the figures and everything, and just maybe you edit it a little bit, or it does all the citations for you. So those are the kinds of features I think we should add using AI on ResearchHub.
Yeah, super cool. Agree wholeheartedly. One of the things we've talked about a couple times during the event today is sort of like the changing landscape of how funding is allocated. So like maybe public funds are becoming like a little bit less sustainable, while actually like funding for early stage biotech is on the rise. So yeah, you've actually helped to start a few biotech companies recently. So curious, like if you could speak to like early career scientists, potentially entrepreneurs, like what do you look for, in a scientist who's becoming an entrepreneur and trying to start a company?
Yeah, well, so there's kind of this classic debate, right? Is like, should the government be allocating capital or should the private markets? And clearly the answer is both. Like, but there's always a question of to what degree and what ratios, right? Like, I think there's you could say there's some projects that are so big and so massive, and there's not any near-term revenue, like, I don't know, the International Space Station or some linear accelerator or whatever, that like it's maybe only government would do it, right? And so we have the NIH. I think it's a huge crown jewel of America. It's had so many downstream dividends. Now, this might be a little contrarian to say, but I think on the flip side, the NIH has some real challenges, right? I mean, it's not a very efficient allocator of capital in many other instances. Like it can be quite risk averse at times, right? It's probably more based on someone's seniority and track record as opposed to like a really high potential young person. It can also become like a lot of these organizations have like very high degree of overhead, operational overhead, where the money's not actually going to the science, it's going to the operational overhead, and they turn out to be more like jobs programs within these universities. And I think sometimes like it can become politicized where it's like, okay, the NIH grants have to go equally to these different states across the US, or whereas there's really like two or three labs that should probably get the majority of that funding if it was more of like a venture capital mindset. So this is a controversial topic. I mean, I'm sure there's people in the audience who have different points of view on it, and I think that's okay. Um, you sort of asked about like creating these biotechs and what my approach is on it, at least, which is just one approach of many. But one thing that whenever you're spending your own money versus other people's money, you're going to spend it more carefully, right? It's just like a sort of a truism. And so when I've invested in these early stage biotechs or that I've had a chance to help start, what I try to do is I do the opposite of the typical top-down build in biotech. Like the typical build in biotech company would be, you find some board members, you find a CEO, you find a CFO, you find like a scientific advisory board, and there's all these like really senior, lofty people, and like the 20th person you hire is actually going to do something in the lab. We've tried with the people I've created these companies with, we try to do more of like a bottoms up build that's more scrappy, more capital efficient. And we have this saying inside New Limit, for instance, the longevity biotech I co-founded, which is like everyone executes. That's one of the values. So everybody who's hired in, even if you're a manager or whatever, you spend some percentage of your time actually in the lab or writing code. And every single of the 40 people who work there now, like every single person is hands-on building a part of the company. And we don't have like a big C-suite, right? We actually don't have anybody in the C-suite. So there's many lessons, but that's a key one that I've thought about of like the way that biotechs die is they can't raise their Series C. There's kind of like it's easy to raise an A or a B, and then you can't raise, so you have to go public too early, and then the public markets crush you. And so you have to be very scrappy and efficient with capital, and ideally find somebody who has made a bunch of money, like in software or something, who is very excited about the company and wants to sponsor it. And I think that can be like a key partner to have in any biotech these days.
Awesome. Yeah, thank you. So the next question I have is around like freedom of speech and sort of like curation of content in science. So traditionally, journals have kind of fulfilled this role as like what's acceptable to be considered science, what's not acceptable based on peer review. There's pretty obviously flaws in that. Preprint servers are like a great improvement. You can share content before it's peer reviewed. And they're thought to be like 100% open, but that's not totally true. There's still some curation in order to like basically create high signal to noise. For instance, Archive, I think like last week or the week before that, decided that they didn't want to have narrative reviews anymore because I think there's just like too much content almost with LLMs creating it. And then we had the executive director here today who said even like if you're an undergrad, you'll just do anything to get an archive paper up because it helps with your career essentially on the CV. So yeah, curious like how you think about like content moderation and like free speech on ResearchHub.
Yeah. So I think just broadly in society, there is a shift happening right now from, trusted centralized institutions or experts to these more decentralized or free market approaches. And you see that in traditional media, where instead of like having a few major media companies and gatekeepers, like people are using social media and podcasts, you see it in like political polls. Instead of trusting pollsters, they're using prediction markets, or like maybe even like universities, people are doing more online learning or whatever it is. And so I think that ResearchHub can play a role that's similar here in the sense of, I think you want to provide a place that any idea can be said, even if it's contrarian. And so there's many times where people put out contrarian ideas, and you want that to be okay. That's how new ideas come up. But you also don't want to have everybody who's with some crackpot unscientific theory, flooding the front page with just unhelpful conspiracy theories or something, right? And so this is something that I think society is grappling with across many dimensions, like I said, and like trust in institutions is at an all-time low if you look at the polls on it. And so I think on ResearchHub, you want to have this balance of like any idea, as long as it doesn't like violate kind of First Amendment stuff, like, inciting violence or something like that. Like basically people should be able to say any idea they want. Now, you might get downvoted for it. People might think that it's bad or it's unscientific or it doesn't replicate. And so the best content should rise to the top organically, but also people should be able to say whatever they think. including contrarian ideas. And it's important to have that. I think it's interesting, like the Bitcoin white paper, which was published not in a journal and the person was anonymous. That's probably one of the most important research papers of the last couple decades. Like it spawned, like a multi-trillion-dollar industry, right? And so in terms of impact, sometimes we're seeing people, put out these things that it doesn't go through some trusted gatekeeper. So we want to make sure that it's okay to do that. And I think we even want to make it okay for people to say things anonymously if they really want to. Like if you don't feel comfortable putting your name and you want to say, hey, this paper is fraudulent or whatever, I think there should be a path for you to put that out there without having to, risk your career or something. Like you'll get more truth out of people if they feel like there's not going to be retribution. So those are just a few ideas.
Yeah, totally. A quote that I really like that I think like helps to kind of encapsulate the perspective here is the way to get good ideas is take a lot of ideas and throw away the bad ones. And so like, get all the ideas out there. And then maybe I think like that's actually a pretty good use case for AI is to help like sort of do the first pass of filtering towards like what's the most valuable of all those ideas. So, okay, last question I have here has to do with DeSci, decentralized science. So yeah, in general, we're within the DeSci industry. Like, how do you think decentralization can help to improve the way that the world does science?
Well, I think that hopefully it can get rid of the paywalls, make it so good ideas can come from anywhere, democratize access to funding, create new kinds of credibility indicators that are not just relying on citations or H-index, and connect research to real world benefits for everyday people. That's how we'll ultimately get more funding into science and technology is like, if the average person thinks like, this is benefiting my life. And I think we all want that. So hopefully with some of these tools, we can accelerate science and accelerate progress in the world.
Okay, great. Awesome. So those are all the questions that I have. We still have another 7 minutes. Does anybody else have any questions they'd like to ask?
Hi, thanks so much for having this conference. So I was thinking about Vannevar Bush, and in a way, he was moving to decentralized science because he was saying curiosity-driven science, let all these individual scientists pursue their individual ideas rather than having kind of a top-down, government-directed science. And so now there's this kind of decentralized science 2.0. And I think that there needs to be kind of, I'm wondering what you think of that. And I'm also wondering what you see as the balance, because it doesn't need to be an replacement. It can be one of the options. So just wondering about the balance and curiosity-driven science.
My understanding is like he was involved in the NSF, right? And I'm not entirely familiar with the history of it, but yeah, if there was an early effort to make it more decentralized and good ideas can come from anywhere, I mean, that sounds appealing. So yeah, I mean, it's sort of true in a lot of times, like a lot of institutions are created with noble ideals. And then, the founders retire or they pass away and there's a succession. Sometimes the people who come in to preside over an institution are not the people who created it in the first place. And so sometimes institutions can decay, they can need to be refounded, right? We're seeing this like inside the universities in many, like all kind, traditional media, like many forms of government. Like that's why I think trust in our institutions is so low, is like many of them have lost trust of the public, but they can basically either be reformed from within or new alternatives can be created. And there's actually a great talk that Balaji Srinivasan gave back in 2012. It's on YouTube, called Silicon Valley's Greatest Exit. But he explores this idea of like, using voice to reform an existing institution versus leaving to create a new one. And actually both are very important. And I guess just as an entrepreneur, my default is exit to create a new one. That's actually the best way you can reform Stanford, is to create a new online learning school that's better. And they'll probably adopt many of those best principles, right? So anyway, it's a classic debate, voice versus exit.
And I think just to back up your perspective there, like there have been a couple of startups trying to think about how to compensate peer reviewers in different ways, and journals are starting to do that because I think the marketplace is saying they have to. So yeah, agree.
Great example, yeah.
Thank you, Brian. My question is maybe less about science, but more about blockchain, decentralization, and AI. I know you're a veteran in blockchain space. I just came from an institutional blockchain conference. Like everyone talking about AI and crypto and the needs of decentralized training for AI, because otherwise it's just centralized on the top for 3 or 4 companies. How real do you think that is? Because the power is now it is now very centralized.
So you're right. There are some people working on blockchain to decentralize compute and create like a economic incentive for these data sets, the training data sets and the compute and the energy. Like essentially anybody could contribute from all over the world and create a more efficient market for that. I've seen some opportunities that are more like venture investment stage, but I haven't seen anything that's being used in practice by any of the hyperscalers. So I think it's too early. I think it's more like venture stage, like Series A in some of these.
Hey, Brian. So my question really is about this comment on making science more accessible to everyday humans, and really whether as part of the vision you see ResearchHub being a conduit to actual patients or actual subjects in scientific research. So as example, patient recruitment for clinical research is a very expensive and largely opaque process. So do you see a way to improve that?
Yeah, well, you're right. I mean, like patient recruitment for clinical trials is, I think, maybe the highest cost or slowest part of those. Yeah, if I understand that correctly. So I do think there's an opportunity for a startup in the market to go make clinical trials, including patient recruitment, much more efficient. I know there's members inside the current HHS and FDA who are looking at opportunities to make that more efficient. Like one of the ideas I heard proposed was kind of like if a drug passed phase 1 for safety, maybe you'd give doctors the option to prescribe it even if it hadn't passed efficacy studies, or there's different things like that you could consider. I wouldn't say ResearchHub is not currently focused on that. I think clinical studies and patient recruitment is its own huge area that deserves further companies to be built. So it's probably a little outside the scope of what we're currently focused on with a small team, but I think it's super important. And yeah, I mean, anyway, I'm sure like many of you, I could go on and on about clinical trials. Like it's so easy to say this, we have to be cautious to protect the next thalidomide or whatever. But like the reality is every good drug that's delayed to market, also costs human lives. And so that side of the equation just doesn't really get factored in the way the incentives are set up. And it's kind of a travesty. Some scientists have told me that even like they'll publish a paper in the US or file an IND and like the drug will be in patients' arms in China before it is in the US, just because they're seeing the patent, I guess, application go out and then replicating and running the trial there. So I guess the last comment I have on that is the law is a function of latitude and longitude. So at least we have some, the way you get better improvements is you need like a competitive market. So the way you can do that today is you can do that in different countries, right? Like Australia, lots of companies are going to Australia to do trials, of course, and UAE is throwing their hat in the ring, even Prospera, right? You can go down the kind of risk curve if you want, but, and then it's once something is de-risked, then you can come back to go through the expensive, longer process in the US. Some of you may have seen this too. The most out there idea I saw was actually people using essentially like brain dead patients who had decided to donate their body to science. And I think there's actually maybe a small number of these that have been used now to run clinical trials where legally the person is dead, but their body is still being kept alive. And there's all kinds of ethical issues about that, but that's an example of the lengths people are going to test drugs in clinical trials in a more efficient way.
So we gotta get a startup for that last thing. That's a company right there, I think. So
yeah.
Okay, great. Well, thank you, Brian. Appreciate it. I think that pretty much wraps up the day. So thank you all. Appreciate it.
Thanks, Sean.
Have a good one.
See you soon. Bye.